Here is a scenario that every AI user has experienced at least once. You run a carefully crafted prompt, the response looks great at first glance, and you use it, only to discover later that something in it was wrong. A statistic that does not check out, a logical conclusion that does not quite follow from the reasoning, a perspective so one-sided it misses half the picture entirely. This is not a rare edge case. It is one of the most consistent challenges in working with AI, and it is one that most people never learn to engineer against. Instead, they either trust everything blindly or spend enormous amounts of time fact-checking and editing output that should have been reliable from the start. In this video, we are going to change that permanently. You are going to learn how to build prompts that are genuinely error-resistant, designed from the ground up to reduce the 5 most common AI failure modes before they happen. And you are going to master bias mitigation strategies that make your AI output more balanced, fair, and trustworthy than anything a basic prompt can deliver. These two skills together transform AI from a tool you use cautiously into a partner you can rely on. Let's get into it. Before you can engineer against errors, you need to know exactly what you are defending against. AI systems have 5 common failure modes, and each one requires a slightly different prevention strategy. The first is hallucination. This is the most well-known AI failure. The model invents facts, statistics, names, or details that sound completely plausible but are simply not accurate. Hallucinations are dangerous precisely because they are confident. The AI does not flag uncertainty. It presents invented information with the same tone as verified information, which makes them easy to miss on a casual read. The second is relevance drifting. This happens when a response starts on topic but gradually wanders away from the original question as it develops. The AI might begin answering your prompt correctly, but by the 3rd or 4th paragraph, it is exploring tangential ideas that are interesting, but not what you asked for. In long responses, relevance drift can mean the most important content gets buried under material that missed the point. The third is reasoning failures. These are logical errors, conclusions that do not follow from the evidence, steps in an analysis that skip important considerations, or causal relationships that are assumed rather than demonstrated. Reasoning failures are particularly tricky because the logic sounds plausible on the surface. You need to read carefully and critically to catch them. The fourth is consistency issues. This occurs when the AI contradicts itself within the same response, stating something in paragraph 2 that directly conflicts with something it said in paragraph 5, or using the same term with 2 different definitions in different parts of the same document. In long, complex outputs, consistency issues are surprisingly common and surprisingly easy to miss. The fifth is context misinterpretation. This happens when the AI misses or misreads a key piece of information in your prompt and builds its entire response on a wrong assumption. The output can be internally coherent and well-written, and completely off base because it started from the wrong premise. Each of these 5 failure modes is manageable, but managing them requires intentional engineering, not hopeful reading. For each of the 5 error types, there is a corresponding prevention strategy that you can build directly into your prompts. Strategy 1, reality anchoring for hallucination. Reality anchoring means tying the AI's responses to verifiable information that you have explicitly provided in the prompt. Instead of asking the AI to draw on its general knowledge for facts and statistics, you supply the data yourself and instruct the AI to work only from what you have given it. The instruction is simple. Only use information explicitly provided in this prompt. If a fact or figure is not included here, acknowledge the gap rather than filling it in. This single instruction dramatically reduces hallucination risk on factual tasks. Strategy 2, self-verification for reasoning failures and consistency issues. Self-verification asks the AI to review its own output before delivering it. After completing the primary task, you instruct the AI to check its response for factual accuracy, logical consistency, direct relevance to the original question, and appropriate level of detail. Then, critically, if you detect a likely error in your response, correct it and explain the correction. This turns the AI into its own quality control system, and it works remarkably well. Strategy 3, Explicit constraints for relevance drifting. Explicit constraints define not just what the AI should do, but what it should not do. Boundary instructions like stay focused specifically on and do not explore related but tangential areas prevent the wandering that causes relevance drift. The clearer your scope constraints, the more focused and relevant your output will be. Strategy 4. Fallback protocols for context misinterpretation. A fallback protocol tells the AI what to do when it encounters ambiguity or missing information. Instead of making an assumption and running with it, the AI is instructed to flag the ambiguity explicitly. If you need to make an assumption to proceed, label it clearly as an assumption and explain why it is necessary. This makes invisible assumptions visible, so you can evaluate them before relying on the conclusions built on top of them. Strategy 5. Fact separation for all 5 error types. Fact separation instructs the AI to clearly distinguish between verified facts, analytical inferences, and opinions. When the AI labels its confidence level, high, medium, or low, for each significant claim, you can immediately see where to focus your verification efforts. Low confidence claims get scrutinized. High confidence claims get a lighter check. This triaging approach makes the whole review process faster and more reliable. These 5 strategies combine into a single, reusable, error-resistant template that you can append to any prompt where reliability matters. Here is the full template. After your main task description, add the following. To complete this task effectively, first, only use information explicitly provided in this prompt. If information is missing, acknowledge the gap rather than making assumptions. Second, for any factual claims, evaluate your confidence level as high, medium, or low, and clearly indicate low confidence items. Third, if you need to make an assumption to proceed, explicitly label it as such and explain why it is necessary. Fourth, after completing the primary task, review your response for factual accuracy, logical consistency, direct relevance to the original question, and appropriate level of detail. Fifth, if you detect a likely error in your response, correct it and explain the correction. That template takes about 30 seconds to add to any prompt, and the improvement in output reliability, particularly on client-facing documents, analytical reports, or any content where accuracy is non-negotiable, is substantial and immediate. Error resistance addresses the reliability of AI output. Bias mitigation addresses something equally important: the fairness and balance of what the AI produces. All AI systems have inherent biases baked in through their training data. These biases do not always show up as obvious errors. They often show up as subtle imbalances, missing perspectives, or a tendency to default to majority viewpoints without acknowledging that other valid viewpoints exist. Left unaddressed, these biases can make your output less useful, less fair, and less trustworthy, particularly when you are creating content for diverse audiences or tackling topics that genuinely have multiple legitimate sides. There are 5 types of AI bias worth knowing and engineering against. Demographic bias is the tendency to favor certain groups over others in examples, assumptions, or recommendations. Recency bias is the tendency to overemphasize recent events or trends at the expense of longer-term patterns. Availability bias is the tendency to overrepresent common, well-known examples at the expense of less familiar but equally valid ones. Framing bias occurs when the way a question is phrased influences the answer. Leading language produces leading responses. And confirmation bias is the tendency to seek and present evidence that supports a pre-existing conclusion while underweighting contradictory evidence. Each of these can be significantly reduced through deliberate bias mitigation instructions. Here are 5 strategies that address all of them. Perspective rotation. Explicitly request multiple viewpoints, including those that challenge the most obvious or mainstream position. Neutral framing. Present your questions without leading language that signals a preferred answer. Demographic balancing. Ask for inclusive examples that represent diverse demographics, industries, and scenarios, rather than defaulting to majority cases. Counter stereotype prompting. Specifically, request examples that break from stereotypical patterns, which expands the range and fairness of the output. And evidence balancing. Request both supporting and opposing evidence for any significant conclusion, so the analysis is genuinely two-sided. Just like the error-resistant template, bias mitigation strategies combine into a reusable block you can add to any prompt where balance and fairness matter. After your main task description, add the following. To ensure a balanced and fair response, first, consider this topic from multiple perspectives, including: second, include evidence and reasoning that both supports and challenges the main conclusions. Third, use inclusive examples that represent diverse demographics and scenarios. Fourth, avoid defaulting to majority perspectives or stereotypical examples. Fifth, acknowledge areas of uncertainty or where legitimate differences of opinion exist.
Sixth, use neutral language that does not favor one position over others. Used together, the error-resistant template and the bias mitigation template create a powerful quality layer around any prompt. Your output becomes more accurate, more reliable, more balanced, and more trustworthy. Not because you edited it afterward, but because you engineered it to be that way from the start. Let's bring this together. In this video, you learned the 5 common AI error types: hallucination, relevance drifting, reasoning failures, consistency issues, and context misinterpretation, and the 5 prevention strategies that address each one: reality anchoring, self-verification, explicit constraints, fallback protocols, and fact separation. You now have a complete error-resistant prompt template you can apply immediately to any task where reliability matters. And you have mastered 5 bias mitigation strategies: perspective rotation, neutral framing, demographic balancing, counter-stereotype prompting, and evidence balancing, combined into a reusable template that makes your output fairer and more trustworthy. From this point forward, quality is no longer something you fix after the fact. It is something you engineer in from the very beginning. In video 8, we move into one of the most powerful and underused areas of prompt engineering: persona and context engineering. You will learn the voice framework for creating AI personas that go far beyond simple role assignments, master strategic constraint design, and discover how to optimize your context window so the AI always has exactly the right information to do its best work. See you in video 8.